Uh, the next thing we will do is the following. Uh, recall that the matrix Aij, the attitude matrix is defined by the equation EI. This is nothing but you write the frame field in the natural frame UIs, right? Okay. Hence, if I take, if I want to compute theta I at a vector V, I can write it this way. So this is by definition V dot product with EI P. But EI is just this expression, right? It is just summation over J, Aij, Uj's. And I can write it this way, J from, okay, AI. These are just some constants. Well, they are functions, but scalars. So I can take them outside the inner product. And here I have just V dot product with Uj. So what is that? That is just, okay, so theta IV is just Aij. And then what is this gadget? This is just Vj, right? Vj. If V is V1, V2, V3, this is just Vj because you take that product with Uj. It just gives us the J coordinate. But this is also equal to the following. This is nothing but dxj evaluated on this vector, right? Dxj at a vector just gives us the J coordinate of this vector, Vj. Therefore, instead of V dot product with Uj, I can write dxj evaluated on the vector field, on the vector V. So I can write it this way. This is Aij dxj summation over j evaluated on the vector V. And this is true. This is true for any vector V in TPM. Therefore, this one form is equal to this one form. Hence, theta I can be written like this. J from 1 up to 3, Aij, and then dxj. Okay, x1, x2, x3 are the coordinate functions of R3, of course, right? X1 at a point P, or x, let's say j at a point P, is just, so xj, P1, P2, P3. This is just the j coordinate function. And its derivative is just a one form which does the same thing to vectors, right? Xj gives us the j coordinate of the point. Its derivative gives us the j coordinate of a vector at that point. Değil mi? Yani xj bir noktanın j'yi komponentini veriyor. dxc ise o noktada aldığınız bir teğet vektörün j'inci koordinatını veriyor. Alright. So the conclusion is that the dual one forms of the frame field EIs is given as like this, right? Where AIJs are the attitude matrix of the frame field A. Okay. Bu sürekli donuyor. Buna ne yapabilirim acaba? Herhalde bu sistemi açıp kapatmak lazım ama nasıl açılıp kapatılıyor? Fişini çeksek. O fişler. Şurada olabilir onun fişi. Evet. O da başladı. Okay. Okay. I hope it will work from now on. Okay. So, theorem. Cartan structural equations. Let EI, theta I, and WIJ be as above. Okay. Then we have the first structural equations. These are the followings. D theta I is summation over J, Wij, wedge product theta J. Theta is the one form, its derivative is the two form. W1J is Ij is a one form, theta J is a one form. So you take wedge product, you get a two form, and theta d theta I is equal to this. So this is the first set of structural equations. For each I have one equation. And then we have the second structural equations, second structural equations. And what is this? This is about the derivative of the one form wij, its derivative, which is the two form, and this is given as like a matrix multiplication. Wik wedge product wkj. Okay. So these are Cartan's equations. The video is still frozen. Okay. Now let's see the proof. Okay, now the proof is the following. Now we have, so first, we have theta I, aij, dxj, right? Summation over j. So that's the equation we obtained here, right? That's just this gadget. Okay, so just this equation. Now, okay, we have this. This can be written as, I can write it this way, theta equals a times dc, where theta is this vector, theta 1, theta 2, theta 3, and dc is this, dx1, dx2, dx3, right? So theta is equal to the matrix A times dxij's, right? dxj's, sorry. So theta is equal to A times dxc. I can write it this way. Now we take the derivative of both sides. D theta will be what? D of A times dxc. Well, A is a function, is a matrix of functions. These are just one forms. You have one forms and then functions. What is the derivative of this? Well, that will be the, we use Leibniz rule again, derivative of this guy. And what we mean by that, we just take D of each entry of the matrix A. Now this is a matrix of one forms. This is another one form. So I need wedge product here. And then this wedge D goes over A. So it will be, but this is a zero form, right? It's a, so it is still plus A times D squared C. If it was one form, then I would have minus here, but now it is a zero form. So D skips the zero form and you get this. But here I have D squared. D squared is always zero. If you take derivative twice, you get zero. So we have this dA times dxc. But what is dA times dxc? So it is exactly what we wanted actually. Değil mi? So let's see. this is equal to what? dA, and then I have okay, let's write down identity matrix here. Bu identity mi? Bir dakika. A transpose A. Yeah, this is an identity matrix. Why is that? Because A is the base change matrix between two orthonormal frames, right? A is the base change matrix of the identity matrix from the frame E1, E2, E3 into U1, U2, U3. They are both orthonormal frames. This is the base change matrix. Therefore, this is an orthogonal matrix. And for an orthogonal matrix, we have A transpose equals A inverse. Therefore, A transpose times A is identity matrix. And I have here this gadget. But these are just scalar objects. These are scalar objects. They are not one forms. I can take these scalar objects and write it this way: dA times A transpose. Here I have, this is matrix multiplication, and then wedge product A times dxc. And remember that this is nothing but our W, and this is just our matrix theta. Okay. Right? We know that W is equal to this one, and this is nothing but theta. Nerede yazdık onu? Şurada yazdık değil mi? Theta is just so theta is just this gadget, so it is just A times dxc. So we have this, then d theta is equal to this gadget, right? This is just theta. Yeah, I already wrote it there actually. For the second statement, which was what? dW is equal to this gadget. Well, this is d of, what is W? W is just dA, sorry, times A transpose, right? Now d of this will be what? Okay, now remember that when you take differential of a matrix, you just take differential of each entry. So I have d of d squared of A transpose, and then I skip a one form, therefore I have minus sign here, dA, and then wedge product of d of A transpose. But here I take d of each entry twice, but d square on any form is 0. Therefore this is 0. Değil mi? Yani bir matrisin differential'ını almak, her bir entry'sinin differential'ını almak. Ama 2 kere differential'ını alıyorsunuz. Bir fonksiyonun 2 kere differential'ını alırsanız o 0 verir. D square her zaman 0. Dolayısıyla bu 0. Burada da bu one formla bu one formu çarpıyoruz. So I have this minus dA wedge dA transpose. And I can write it this way. Again, minus dA. Here I write A transpose A, and then wedge product dA transpose. Now this is a scalar matrix. It is again identity, right? This is just identity matrix. And I can do this. I can separate this and write it this way: dA times A transpose, wedge. I take this A to the other side, A times dA transpose. Because these are scalar functions, I can separate them. Okay, separate them. No problem. They can go, yani şöyle 3dx dy'ı şöyle yazmak gibi. Dx wedge 3dy. Right? Scalars can go freely, okay, over the wedge sign. But what is this? This is just W. Well, minus W. Wedge product, what is this? Well, if you look at this, this is nothing but transpose of this gadget, right? So this is W transpose. However, W matrix, W was this, right? Wij's, and its transpose is Wji's, but this matrix was skew symmetric, so this is just minus Wij. Therefore, this is just minus W. Its transpose is its negative, so this is minus W, wedge minus W. So this is just W wedge W. Okay. W wedge W means what? Let's see. Let me erase this. So ijth entry of this matrix, ijth entry of this is just what? Okay, so this is summation Wik wedge W K J. K from 1 to 3. Değil mi? İki tane matrisin çarpımının i'inci entrisi nedir? Birinin i'inci, bunun i'inci satırıyla bunun k'inci kalımını alıp çarpacaksınız. Değil mi? O da buna eşit. Okay. So this finishes the proof, okay? Here, of course, we have, matrix multiplication of one form, matrices of one forms, right? This W is just this gadget. Its transpose is this gadget, and I multiply them as matrices, but whenever I multiply the entries, I multiply them as one forms. Yani bunlar entry'leri one form olan matrisler. Matris çarpımı yapıyorum ama entry'lerini çarparken onların one form olduğunu hatırlıyorum. Dolayısıyla bu şuna eşit değil. Yani bu ikisinin yerini değiştiremem. İki tane one form'un yerini değiştirirseniz çünkü işareti eksiye döner. Hani onu da akılda tutacağız. Tamam mı? Genelde matris işlemlerini yaparken Yani matrislerle ilgili işlemler ya da linear algebra yaparken ringinizi komutatif alırsınız. Yoksa matris işlemleri içinden çıkılmaz hale gelir. Determinant hesaplayamazsınız mesela. Ama burada hani biraz eğip bükerek bu şekilde yapıyoruz. Notasyonu. Okay. All right, let's do one example. Let's move to 3. Okay. All right. Consider the spherical coordinates given by this. X1 is rho times cosine phi cosine nu. X2 is rho times sine phi cosine nu, and X3 is rho times sine nu. So let's say this is X1, X2, X3. If I have a point here, I look at its projection in the XY plane or X1, X2 plane. This angle here is this phi, and this angle is which angle? The angle between these two. Cosine olduğuna göre, evet. So this is 90 degrees, right? This is 90. This is nu. Okay. X1, X2, X3. Ama buna uygun olanı bu. Modified spherical coordinates. Şimdi şöyle bir convention'ımız var. Frame field'ı yazacağım. Bunun yönünde türev ve E1, bunun yönünde türev E2, bunun yönünde türev E3 alacağım. Yani evet, R3 boyuttayız. 3 tane değişkenimiz var. Bu birinci değişkenim, pardon şöyle diyeyim, E1, E2, E3 demeyeyim de buna. Bu birinci değişkenim, bu ikinci değişkenim, bu üçüncü değişkenim. Kartezyen koordinatlarda buna gerek yok. Zaten onları x1, x2, x3 diye yazıyorum. Ama rastgele bir koordinat sistemi seçtiğimde hani UV seçersem onun eğer sonra numaralandıracaksam hani E1, E2, E3 gibi, o zaman hangisine ilk koordinat, hangisine ikinci koordinat, hangisine üçüncü koordinat dediğimi hatırlamam lazım. Bu birinci koordinat, bu ikinci koordinat, bu üçüncü koordinat. Tamam mı? Şimdi şu var elimizde. Since theta I ben şimdi bu yönlerdeki şeyleri yazacağım. EI'ları yazmam lazım. Hani E1, E2, E3. Frame field'ı yazacağım. Frame field'ı dolaylı olarak yazacağım şöyle. Şimdi bunları bulmak istiyorum. İsterseniz hatta şöyle diyeyim. To compute the frame field E1, E2, E3, we use the identity dual frame kullanıyorum. Dual one formları kullanıyorum. Theta I, Aij, dj. Where Aij'de neydi? Aij EI ile UJ'in inner product'ı. Değil mi? Aij dediğim şey bu böyle tarif edilmişti ve theta I da Aij dxj'lerde yazılmıştı. Şimdi şöyle yapacağız. Ha yok. E'leri bulmak sorun değil de şöyle diyeyim. Tamam neyse. Bunları silebilirim. Frame field and AIJs. Şöyle yazayım. Okay. So to compute all this machinery, we will use these equations. And what are the EIs? EIs are the orthonormal frames obtained from the coordinate functions. E1 is the derivative of which curve? So I write it, okay, now rho okay. Şöyle diyeyim. X1, X2, X3 is rho times cosine phi, cosine nu, rho times sine phi, cosine nu, and rho times sine nu. E1 is the derivative of this with respect to the first coordinate. So this is just the row of this, gadget. I consider this as a curve in R3. This is the parameter. I keep this angles constant and just change this parameter, and I just take the derivative of this curve. What is the derivative of this with respect to rho? But this is just cosine phi, cosine nu, sine phi, cosine nu, and sine nu. E1 is this. And then I have to divide this by the length of this vector, right? I want unit vector, so length of this. But if you square all these and add them up, you get 1. So this is in this case equals 1. Therefore, E1 is just this vector field. No, this is cosine and this is sine. You can check that this is a unit vector, okay? E2 is what? E2 is just theta derivative of this, not theta, sorry. The second variable is phi. So I take derivative with respect to phi of x1, x2, x3, and then I will divide this by the length of whatever I obtain. When you take derivative of this with respect to this gadget, you get what? Minus rho times sine phi cosine nu, rho times cosine phi cosine nu, and derivative of this with respect to phi, that is 0, divided by the length of this vector. Because I want a unit vector, bununla bunun kareleri topladığında rho kare, buradan 1 gelecek, buradan cosine kare gelecek. Demek ki bu rho kare cosine phi, sonra da bunun karekökünü alıyorum. Dolayısıyla bunu elde etmiş oldum. Buradan da ne çıkar? Rho ve cosine gideceğine göre minus sine phi, değil mi? Sine phi, and then cosine phi, no, cosine phi değil, sorry, this is evet, sine phi diye, özür dilerim, sine phi, cosine phi ve 0. So E2 is this, and if you compute E3, so let me just do it over here. E3 is, so d theta with this d over d nu of what? The same expression, rho times cosine phi cosine nu, rho times sine phi cosine nu, and rho times sine nu. I take derivative with respect to nu and divide this by its length. Let me just give you the result, okay? This is just minus cosine phi sine nu. Türevini aldığım için, değil mi? Buradan minus sine gelecek. Buradan da sine phi. Bunun da önünde eksi var ama. Çünkü bunu türev aldığım için buna göre sine phi sine nu ve buradan nu gelecek. Vektörler bunlar. Okay. Okay, so what are the AIJs? Remember, AIJ is the jth component of the vector EI. So this is A11, this is A12, this is A13, this one is just A21, this is A22, and this is A23, A23, yes, and this one is A31, this one is A32, and this one is A33. All right. So we can write down our theta. Okay, now theta 1, this is just A1j dxj summation over j. So this is just A11 dx1, A12 dx2, and A13 dx3. Okay. So I am using this formula over here. And if you compute this, okay, yeah, we need to also write down what is dxi's. Okay, so these are right, x1, x2, x3 are these functions. So I have to take d of these also, okay, and put into the formula. I know what these are, and I need to compute also d of these gadgets. Okay. A11 is what? A11 was neredeydi o? Ha, cosine phi, cosine nu. Cosine phi, cosine nu. And then dx1. X1 is rho times cosine phi, cosine nu. When you take d of this, you do what? You take its derivative with respect to the first coordinate, and then second coordinate, and third coordinate. So let me write down. When you take derivative with respect to the first coordinate, you get cosine phi, cosine nu, and then d of the first coordinate, d rho, minus y minus, okay, when you take derivative with respect to the second coordinate, which is phi, you get minus sine. So this is rho times sine phi, cosine nu, and then here I have d phi, minus, again, I take derivative with respect to nu, so minus rho times cosine phi, cosine nu, d nu. So it is just this term, okay, plus A12. A12 is, let me tell you what it is. A12 is sine phi, cosine nu. And then I have dx2. Dx2. X2 is this. Rho times sine phi cosine nu. I take differential of this. So let me tell you what the result is. Differential of that. Sine phi cosine nu d nu d rho minus rho times cosine phi evet. Çünkü sinüstü türevini aldık. Kosinüs oldu. Ama bu artı olması lazım değil mi? Evet. Eksi rho times sine phi sine nu d nu plus A13. A13 is what? A13 is just sine nu. Doğru yazdım değil mi? And then differential of x3. What is the differential of this? Sine nu d rho plus derivative of this with respect to nu d nu. And if you compute all these, many things will cancel out, and the result is just d rho. Okay. So so theta 1 is just d rho, that one form. Similarly, siz de bir kontrol edin, yani doğru mu yapmışım gerçekten. Similarly, theta 2. What is theta 2? Theta 2 is just A21 dx1, A22 dx2, A23 dx3, and this becomes, let me just tell you the result, rho times cosine nu d nu, and theta 3, which is just A31 dx1, A32 dx2, A33 dx3, and this is just rho times d phi. Okay, so we computed thetas also, and we have the matrix A.Wij's are, remember, these are just summation over k, ajk, d aik, and if you do the computations, W12, remember, this is a skew symmetric matrix, therefore Wij is equal to minus ji. In particular, Wi's are 0, so I have only 3 non-zero terms: 1, 2, 1, 3, and 2, 3. W1, 2, if you just, compute all these, I have this Aij's, and I need to take their differentials and multiply them out. This is what you will get. This is just cosine phi d nu. 1, 3 is just d phi, and 2, 3 is sine phi d nu. Okay. Bu gene donmuş. Ops, 35 mi oldu saat? Şöyle diyeyim o zaman. Okay, now from this second board, one can compute the theta i's and the wij's. I will not do these, but I will put the notes to my web page, so you may copy them from there. Okay. Burada neyi kullanacağız? Yani işte d theta dediğimiz şey, d theta I is just wij's wedge theta j summation over j, and wij differential of that is just summation over k wik wedge wkj. Okay. We computed all these gadgets. You just plug them and obtain the results. Okay. Peki. Dediğim gibi hani bunlarla ilgili soru sormam sınavda. Stop.